Our lecture for today is the focal length of a convex lens by a graphical method. While the eye has some striking similarities to a camera, a better analogy exists between the eye and a closed-circuit color TV system. As shown in this photo, the lens of the TV camera is the cornea and lens of the eye. The signal cable is the optic nerve. The viewing monitor is the visual cortex. The refractive interfaces in the lens system of the eye, as shown in this photo. 1. The interface between air and the anterior surface of the cornea. 2. The interface between the posterior surface of the cornea and the aqueous humor. 3. The interface between the aqueous humor and the anterior surface of the crystalline lens of the eye. 4. The interface between the posterior surface of the lens and the vitreous humor. Focal length of a lens, the distance beyond a convex lens at which parallel rays converge to a common focal point is called focal length of the lens. The relation of focal length of the lens f, distance of the point source of light from the lens u, and distance of focus on the other side of the lens v is expressed by the following formula. 1 over f is equal to 1 over u plus 1 over v. Measurement of the refractive power of a lens. The more a lens bends light rays, the greater is its refractive power. This refractive power is measured in terms of diopters. The refractive power in diopters of a convex lens is equal to 1 meter divided by its focal length. P is equal to 1 over f. I conditions, I, for normal vision emmetropia. The eye is considered normal or emmetropic if parallel light rays from distant objects are in sharp focus on the retina. As shown in this photo, E for defect vision emmetropia is the defective eyesight due to focusing refractive problem. There are 4 types of emmetropia. 1. Myopia, which is also known as nearsightedness, is usually due either to an eyeball that is too long or occasionally to a lens system that is too strong, as shown in this photo. To hyperopia, which is also known as farsightedness, is usually due either to an eyeball that is too short or occasionally to a lens system that is too weak, as shown in this photo. 3. Astigmatism is a refractive error of the eye that causes the visual image in one plane to focus at a different distance from that of the plane at right angles. In astigmatism, the cornea or lens of the eye is not symmetric. For presbyopia, as a person grows older, the lens grows larger and thicker and becomes far less elastic, partly because of progressive denaturing of the lens proteins. Therefore, the ability of the lens to change shape progressively decreases with age. The lenses are used to focus light and form an image in cameras, telescopes, microscopes, eyeglasses, and even in our eyes. Lenses work very much like mirrors. We will discuss 2 types of lenses. Concave lenses. The double concave lens is a diverging lens. When light waves from an infinitely far object passes through the lens, the light waves will diverge as if it originated from a focal point f on the principal axis. The focal length is always a negative value for diverging lenses, as shown in this photo. Convex lenses. The double convex lens is a converging lens. When light waves parallel to the principal axis from an infinitely far object passes through the lens, it will converge at a focal point f on the principal axis. The distance between the focal point and the lens is the focal length, which is always a positive value for converging lenses, as shown in this photo. Correction of eye defects. Myopia. Nearsightedness. Concave lens is used to correct the myopic persons. Hyperopia. Farsightedness. Convex lens is used to correct the hyperopic persons, as shown in this photo. Astigmatism. To correct for astigmatism, the usual procedure is to find a spherical lens that corrects the focus in one of the 2 planes of the astigmatic lens. Then an additional cylindrical lens is used to correct the error in the remaining plane. To do this, both the axis and the strength of the required cylindrical lens must be determined. The medical applications of lens. 1. To determine the focal length of the eye and distance between the object and the lens. 2. For the treatment of the eye defects like far-sight vision, near-sight vision, old age vision, and astigmatism. 3. It is used in many medical and biological devices like microscope, ophthalmoscope, otoscope, and endoscope, etc. 4. In dentistry, it is used in many devices and instruments like dental chairs, mouth mirror, and etc.